In this class, now I am going to discuss with you slope form of pair of straight lines passing through origin. Consider this coordinate system. In which there are two lines which are passing through origin. Let us name whose equations as y equal to m1x and y equal to m2x. But as you people know that pair of straight lines passing through the origin will be in this form: ax square plus 2hxy plus by square equal to 0. It is a homogeneous equation which contains two line equations which are passing through the origin. But here I have taken those two line equations as y equal to m1x, where m1 is the slope of this line, and this is y equal to m2x. m2 is the slope of this line. Now I am going to multiply these two line equations. So if I multiply these two, I get like this: m1x, shift this y to the right side so that you will get m1x minus y into, and this one transfer y to the right side so that you get m2x minus y, which is equal to 0. Now take the product of these two binomials, m1 into m2x square, and multiply this with this, you get m1xy. Multiply this with this, m2xy. Now minus into minus plus y square, which is equal to 0. See here, m1 m2 x square. From these two take minus xy common. So here you get m1 plus m2 xy plus y square, which is equal to 0. On multiplying these two line equations, I got this one. Now I am going to compare this one with this. But observe both of them. Here y square coefficient is b, here y square coefficient is 1. So now I would like to make y square coefficient in this equation as 1, because here I got coefficient of y square is 1, hence I am going to make coefficient of y square as 1 in this. To get 1 here, I should multiply both sides with b. So multiply both sides with b. Here a by b x square plus 2h by b xy plus y square, which is equal to 0. Now compare these two. On comparing these two, so in the place of m1 m2, a by b is there. So in the place of minus of m1 plus m2, 2h by b is there. So see here, minus of m1 plus m2, which is equal to 2h by b. If you multiply both sides with minus, so that you will get m1 plus m2, which is equal to minus 2h by b. Remember these two relations. So this is the sum of the slopes of these two lines, minus 2h by b, and a product of the slopes a by b. So when you go to the problems, so this pair will be given to you, as you know, which have two line equations, and they will ask you to find sum of the slopes of lines represented by this pair is how much. In such case, you can use that minus 2h by b formula. And what is the product of the slopes of lines represented by this, which means that you have to apply a by b formula. Okay students, I hope you have understood how these relations have come. Next, sometimes they may ask you difference of the slopes of the lines represented by this. Difference of the slopes of the lines represented by this pair, which means that you would have to find mod of m1 minus m2. This you have to find. So, this you can write like this. One standard identity is there. Difference of slopes is equal to square root of sum of the slopes whole square minus 4m1 m2. You read this relation, in which I am going to write m1 plus m2 as minus 2h by b. If I write here, it becomes 4h square by b square minus 4m1 m2. A by b you will get. Now let us simplify this, so that you will get 4h square minus 4ab by b square. So root of, see here, from these two take 4 common, 2 into root of h square minus ab by mod b. Mod b you would have to write, because this is going to come from the square root, hence it should be always positive. Here I kept the modulus symbol, so hence this difference must be positive. So how much do you get? 2 into root of h square minus ab by mod b. This is positive quantity, hence this should be also positive. Hence I kept here modulus symbol. So remember, like a standard formula. So there we have read sum of the slopes as minus 2h by b, product of the slopes a by b, and the difference of the slopes 2 into root of h square minus ab by mod b. Okay students, right. Next, see, suppose if the slopes of the lines represented by this pair in the ratio k is to L, k is to L, then we get this relation k plus L whole square into AB, which is equal to 4h square KL. Whenever the ratio of slopes of the lines represented by this pair in k is to L, then you get this relation k plus L whole square into AB, which is equal to 4h square KL. So when you go to the application part, among this A, H, B, k is to L, this ratio will be given to you, and among this k, H, B, in these three, 2 constants will be given to you. One unknown value they will write there, and they will ask you to find that unknown value. In such case, you have to use this relation k plus L whole square into AB, which is equal to 4h square AB, 4h square KL. Whenever the ratio of slopes of lines represented by this pair is k is to L, then you get this relation k plus L whole square AB, which is equal to 4h square KL. If you want, I can tell you whose proof also. See, students, ratio is given, but that exact slopes we do not know. In such case, you would have to consider m1 is equal to some k into t. T is any real number, like a parameter. Now m2, which is equal to LT. Now see, take the sum of the slopes. m1 plus m2 is equal to, when you add these two, you get k plus L into t. When you take the product of these two, what do you get? Whose product? m1, m2. Take the product of these two, KL into T square. Okay, right. Now, see, from this, okay, m1 plus m2, which is equal to minus 2h by b. Right. So here k plus L into T. Now square on both sides, you get 4h square by b square, which is equal to k plus l whole square into t square. Okay, here m1 m2 is nothing but a by b. So kl into t square. Make t square as common so that you will get a by b into kl. So substitute this value in this. So if you write there 4h square by b square, so which is equal to k plus l whole square into, in the place of t square, write this value, a by b into kl. Now simplify this. On simplifying, what do you get? So here b square, which can be written as b into b. One of the b cancel. So take cross multiplication so that you will get k plus l whole square into k plus l whole square into ab, which is equal to, see students, k plus l whole square ab into 4h square kl. So remember, like a standard result, which helps you while doing the applications. Ratio will be given to you, and among that AHB, in that 3, 2 constants will be given, one unknown they will write like k or pt, some unknown value, variable. So they will question us to find that unknown value. In such case, you have to use this relation, k plus l whole square into ab, which is equal to 4h square into kl. Suppose if the ratio is in the 2:1, if k is to l is equal to 2:1, then collect k value as 2, l value as 1 and substitute here. K plus l, 2 plus 1, 3, 3 square, 9, 9ab, which is equal to, here k into l, 2 into 1, so 8h square you will get. Whenever the slopes are in the ratio 2:1, then you get this relation, 9ab is equal to 8h square. Okay students? Right. Next, suppose if one root is nth power of other, okay, one root is nth power of other, means here root is nothing but slope. So that pair has two lines which has slopes. So slope of one line is nth power of other. Okay, these are what? These represents the slopes of the lines represented by that given pair, ax square plus 2hx square plus by square is equal to 0. So how are these two slopes? Slope of one line is nth power of other. Here if it is alpha, then it is alpha power n. So in this case, you get this relation, a power n into b whole power 1 by n plus 1. So here a b power n whole power 1 by n plus 1 plus 2h, which is equal to 0 you will get. If you want, I can give you whose proof also. See, take the sum of the slopes, alpha power n plus alpha, which is equal to how much? Sum of the slopes, just now we read, minus 2h by b. And the product of the slopes, alpha power n into alpha, which is equal to a by b. Now here it is looking like a power m into a power n equal to a power m plus n plus 1, which is equal to a by b. Now transfer this one to the right side, a by b whole power 1 by n plus 1. You got alpha. Now alpha value substitute here. This alpha you would have to substitute in this. If you substitute there, a by b whole power, here n, here 1 by n plus 1 is there. Hence it will become n by n plus 1 plus alpha value a by b whole power 1 by n plus 1. Now which is equal to minus 2h by B. Now let us simplify that. If you simplify, you will get your required relation. Yes. See, bring this B to the left side so that here you get A power n by n plus 1 into B here. B power 1 by B power n by n plus 1. So here also A power 1 by n plus 1 whole by into here B is there. Because we are taking this B into the left side, so that you will get B power 1 by B power 1 by n plus 1. Now which is equal to minus 2h. So here it is looking like A power m by A power n, which is equal to A power m minus n. So A power n by n plus 1 into B power 1 minus n by n plus 1. So here also A power 1 by n plus 1. So when it goes to the numerator, B power 1 minus 1 by n plus 1, which is equal to minus 2h. Minus 2h. Now simplify that. It is going to be A power n by n plus 1, and here when you take cross multiplication, plus n minus n cancel, B power 1 by n plus 1 you will get. Here also A power 1 by n plus 1, when you take cross multiplication, so you get B power. So what do you get, students? N by n plus 1. So bring this 2h to the left side, 2h which is equal to 0. So this can be written as A power n b whole power 1 by n plus 1, and this is to be written as AB power n whole power 1 by n plus 1 plus 2h is equal to 0. Now you got your required relation. Okay, students. Now suppose if one root is square of other, means in the place of n what did I write? 2. One root is square of other. If I ask you, then simply what you have to do? In the place of n you have to write 2. If I write in the place of n 2, then it will become A square b whole power 1 by 3. And what about this? AB square whole power 1 by 3. So this plus 2h, when it goes to the right side, minus 2h you will get. Now cube on both sides. Cube on both sides. So it is going to be A square by A square b, and here AB square, you know, students, A plus B whole cube formula, A cube plus B cube plus 3AB. 3 into A means, so here it is going to be A power 2 by 3, B power 1 by 3. So this is B. A power 1 by 3, B power 2 by 3. Bracket of A plus B. A plus B means in place of that you can write minus 2h, which is equal to 8h cube you will get. I hope you have understood this step. I took cube on both sides. So here it is A cube plus B cube plus 3AB of A plus B. So 8h cube. Now simplify this. A square B, AB square. So on simplifying these two, base is same. Power should be added. So that you get here A and here you get B. So 3AB. And here minus is there. So what do you get? 3 2s are, okay, minus here, 3 into minus 2, which becomes minus 6. Minus 6 AB, ABH, which is equal to 8h cube. So still if you want to do any simplifications you can. Otherwise you can leave like this. So you can send this one to the right side. So here from these two you can take AB common, AB of A plus B. See here we took cube on both sides, here minus you will get, minus 8h cube. When you bring minus 8h cube to the left side, you get plus 8h cube plus 8h cube. Okay, students, plus 8h cube. Now send it to the right side, 6abh. So, this is the required relation when one root is square of other. Okay, students, I think how I have generated this relation, you have understood. Simply in this relation, I kept n equal to 2, then I went for simplification so that I got this relation. Okay, students, I hope you have understood this. Thank you, students.